We have learned about the derivatives of all types of functions. Now we need to move on to applications of derivatives. One of the applications of the derivatives is related rates. In related rates problem, one quantity is expressed in terms of another quantity, and both quantities are changing with time. Say I have y equals to fx. See, y quantity is expressed in terms of x quantity, and both x and y are actually a function in terms of time. They are changing with respect to time. So this will be gt, this will be a function in terms of t. In order to solve a problem on related rates, we can use chain rule. How? Say y equals to fx. I can derive y where we get dy over dx equals to f prime x. And let's say given y equals to gt, I also can derive y with respect to time. So here I get dy over dt equals to g prime t. The question asks us to find dx over dt. In order to do so, first we apply the chain rule, where chain rule tells us that dy over dx will be equals to dy over dt times dt over dx. This is the chain rule, where at first I put dy on the numerator times another term with dx as the denominator. In between, I put dt, because for related rate problem, it must be related to time. So I put dt, the difference in time. Technically, dt and dt can be cancelled. So we actually will get dy over dx, which is equivalent to the left-hand side, right? So this is the chain rule. In order to get dx over dt, which is related to this, I bring to the left, I get dx over dt, and it will be equivalent to dy over dt. dy over dx, bring to the right, becomes division, divide by dy over dx. So from here, we substitute dy over dt and dy over dx, and we will get dx over dt by using dy over dt divided by dy over dx. So solving a problem on related rates, we use chain rule. Instead of using chain rule, we have another option. We can actually apply the implicit differentiation. However, here we need to differentiate with respect to time instead of differentiate with respect to x. Basic idea. Say the length of the shadow is changing at the rate of 2 cm per second. When you see this statement, you must know how to convert to mathematical form. So the length of the shadow, you let this be a variable, say L. It is a variable because it's changing, right? Changing with respect to time in second. So it's changing at the rate of 2 cm per second. So this means there is a difference in the length over the difference in time. The rate of change means dl over dt here. The rate of change of the length is equals to 2. However, we are not sure whether the length of the shadow is getting longer or shorter. So we just leave it as 2. So this is how we interpret the information given by the question. The area of the circle is decreasing at the rate of 4 meters square per second. See, meter square talking about the area. So when I see this statement, the rate of change of the area is changing dA over dt. Difference in the area over difference in time is equals to, because the question mentioned that it is decreasing. When something is decreasing, the rate will be of negative sign. So it is negative 4. This is the rate of change of the area of a circle. the rate of increase of the volume of a cylinder is 10 cm cube per minute. Cm cube indicate that it is volume, per minute indicate that the time, unit is in minute. The rate of increase of the volume, this means we are talking about the change of the volume, so it is dV over dt equals to, because increasing, so it must be of positive sign, equals to 10 cm cube per minute. So I hope you know how to interpret the information given by the question and convert it to a mathematical form first. Let's see the example. A spherical mothball is dissolving at the rate of 8 pi cm cube per hour. So when I see the unit, cm cube indicates the volume. It is changing with respect to the time in our sphere. We are talking about the volume of a sphere mothball. So dissolving means decrease in size. So based on the information, I know that in mathematical form for the first statement, we need to write it as dV over dt equals to negative 8 pi. How fast is the radius of the mothball decreasing? The question talk about how fast is the radius of the mothball decreasing when the radius is 3. So the question is asking for the rate of change of the radius. You want to know how fast is the radius is changing. So dr over dt equals to question mark. Okay, need to find it out when the radius is 3 cm. First, double confirm the unit, no issue. There is no conversion is needed. Okay, what is the first step in solving related rates problem? First, identify the information given by the question. Write it in mathematical form. They give us the rate of change of the volume. The question asks for the rate of change of the radius when radius is 3. So from these two rate of change, first, you must know the variable other than the time. This is V and the R. The variables are V and R. In the first step, you need to form a formula in terms of V and R. This is the first step. Why do I know the formula must have V and R? It is from the information given by the question. We identify the variables other than T. After we have the formula, make sure it is in terms of two variables, V and R only. Then, in the second step, we can derive the formula. After derivation, in third step, we apply chain rule to answer the question. So let's start now. First, form a formula in terms of V and R, volume and radius. Volume is the volume of the sphere. We know that volume of the sphere is 4 over 3 pi r cubed. Check in terms of two variables, the rest are constant. V and R, 4 over 3 pi are just constant. We can differentiate. When we differentiate V in terms of R, we get dV over dr, which is equals to, let's differentiate, follow the technique that you have learned. 4 by 3 pi, just a constant multiple, we keep, derive r cubed, 3r squared. Simplify it, we get 4 pi r squared. This is dV over dr. Now, after derivation, we use chain rule to answer the question. The question asks for dr over dt. dr over dt will be equals to, put dr and dt separately. In between, what do you put? Other than t and r, we have one more term, that is v. So in between, we put dv, which is equals to, what is dr over dv? We have dv over dr here. dr over dv will be the reciprocal of this, so switch it. 1 over 4 pi r squared times dv over dt given by the question, negative 8 pi. So simplify, substitute r, which is 3, we get negative 2 over 3 square, that is equals to negative 2 over 9. This is the rate of change of the radius, so it is cm per hour. Follow the unit. In solving related rates problem, first, we identify the information given by the question. We form a formula in terms of two variables. Then we differentiate the formula. And in the last step, we apply chain rule to answer the question. Number 2. For an inverted cone of height 60 cm and the base radius 20 cm, the base is held horizontal and uppermost. So it is an inverted cone where the base is uppermost. See, the base is on top. Volume. The radius is 20 cm. The height is 60 cm. Water is poured into the container at a constant rate of 40 cm cube per second. Cm cube indicates volume. So pour the water in. The difference of the volume over the difference in time is equals to 40. Why I put positive sign instead of negative sign? Because when I pour water into this cone, initially, this is the height of the water. After some time, do you notice the volume is increasing? Volume is increasing, so the rate must be positive. So this will be the changing in the radius over time, and this is the variable h. Part 1. Find the volume of the water in the container when the depth of the water in the container is x cm. Write your answer in terms of x. So the question asks for the volume function in terms of x. First, volume of a cone is 1 over 3 pi r square h. Don't worry about the general formula of the volume. It is given in the question. So volume is 1 by 3 pi r square h. Based on the condition given by the question, we notice that both radius and the height are variable. They are changing with respect to time. When the volume is getting more and more, the radius is getting bigger and bigger. The height is also getting bigger and bigger. So r and h are variables. Same goes to volume. As mentioned earlier, we need to ensure our formula is involving two variables. So for inverted cone, we can have relation between radius and height. We have similar shapes. Do you see that? There are two similar shapes here. The bigger triangle and the smaller triangle. The bigger triangle is 20 for the radius and 60 for the height, given by the question. 60 here, 20, 60. And for the smaller triangle, this is the variable r, variable h. 20 over r will be equals to 60 over h. For similar shapes, the ratio are the same. In order to write the answer in terms of x, which is related to the depth, so I write r in terms of the height, the depth. Cross multiply, 20h equals to 60r. R will be 20 over 60h, which is 1 over 3h. Let's substitute r equals to 1 by 3h into the function. Volume equals to 1 by 3 pi r square, which is 1 over 3h square h. Expand it, 1 by 3 pi. 1 over 3h square becomes 1 by 9h square h. volume will be 1 over 27 pi h cubed. The question asks for the volume when the depth of the water in the container is x. So it means h equals to x. Substitute h equals to x, then we get the volume, which is equals to 1 over 27 pi x cubed. This is the answer for part 1. For part 2, find the rate of increase of x. When I see this, we need to find the difference of x over the difference in time. Find dx over dt. When x equals to 2, leave your answers in 2 decimal places. Earlier, we have v equals to 1 over 27 pi x cubed. So write it down. We have the function involving only 2 variables. In order to solve for the related rates problem, first we derive this formula. Differentiate v in terms of x, we get dv over dx, which will be equals to 1 over 27 pi, keep as constant multiple, derive x cubed, we get 3x squared. Here we have pi x squared over 9. After differentiate the formula, we apply chain rule. To get dx over dt, it is equals to dx times over dt. In between, what do we put? We put dv. So which is equals to dx over dv is reciprocal of dv over dx. So it will be 9 by pi x squared times, for dv over dt, earlier given by the question, dv over dt is 40. So with times 40, substitute x equals to 2. So we get 360 over pi 4. 2 squared is 4, equals to 90 over pi. The rate of change of x. X is the depth. So the height is in cm per second. Number 3. A conical tank, again a cone shape, has radius, length at the top. So again the radius is at top, equal to its height. The radius is equals to the height. So we put it down, r equals to h. This is the conical tank. Water initially with a depth of 16 cm. Initial depth is 16 cm. Leaks through a hole in the bottom of the tank at the rate of 4 h cm cubed per minute. Volume again. There is leakage. The rate of change of the volume, dv over dt equals to, because of leakage, the volume in the tank is decreasing. So the rate of the volume must be negative 4 h. Where the depth is h cm at time t minutes. At what rate is the depth of the water? So the question asks for the rate of change of the depth, dh over dt. At what rate is the depth of the water? How fast is the depth changing? So difference in height over difference in time. When the depth of the water is 9, when h equals to 9. First, we need to form a formula. The formula must be, what do you think? Must be in terms of v as well as h, volume and height. Volume of a cone, 1 over 3 pi r squared h. When the water is leaking out from the tank, the water is decreasing in the volume. We notice the variables are radius as well as the height together with the volume. Involving 3 variables, we need to reduce to 2. In order to reduce to 2 variables, we need to know the relation between r and h. Question already mentioned, r is equals to h. So we need to replace r with h or h with r. So which one? check the question. The question asks for the rate of the depth, rate of the height. So the formula must be in terms of h, not r. So we replace r with h. V equals to 1 over 3 pi h squared h, which is pi h cubed over 3. See, we have formed a formula involve only two variables that we need, which are v and h. V and h. Next, differentiate the formula. Differentiate v in terms of h. dv over dh will be equals to pi over 3 stay 3h squared, which is pi h squared. After derivation, we answer the question by using chain rule. Get dh over dt. dh over dt will be equals to dh times over dt. In between, we put dv, because given by the question, which is equals to dh over dv is the reciprocal of dv over dh, 1 over pi h squared times dv over dt is given by the question, negative 4 third h. The h is equals to 9. Let's sub in 1 over pi 81 times negative 4 third 9, which is equals to negative 12 over 81 pi. We can further simplify. Negative 4 over 27 pi. dh over dt, height versus time, cm per minute. The steps to solve related rates problem are always the same. First, get the formula. What formula to be formed? It depends the information given by the question. So we need to form a formula with v as well as h. After form the formula, involve the two variables. We derive the formula. After the differentiation, we answer the question by using chain rule. 4. A 17-feet ladder is leaning against a wall. If the bottom of the ladder is pulled along the ground away from the wall at a constant rate of 5 feet per second, how fast will the top of the ladder be moving down the wall when it is 8 feet above the ground? Too many information. Let's go through again. A 17-feet ladder is leaning against the wall. So now I have ground as well as the wall. There is a 17-feet ladder leaning against the wall. If the bottom of the ladder, this side, is pulled along the ground away from the wall, pulled away from the wall with a constant rate of 5 feet per second. So let's visualize the condition after I pull the ladder, pull the bottom of the ladder away from the wall. So the ladder will slip down and we have a situation like this. I notice this length is increasing. So I let this be a variable x. According to the question, the rate of change of x is 5 feet per second. Positive sign because getting larger. Do you see that? How fast will the top of the ladder moving down? The top of the ladder initially is here. After I put the bottom of the ladder away from the wall, so the top of the ladder is decreasing in size, lower. So the question asks for the rate of it. How fast will the top of the ladder be moving down? Question asks about dy over dt. When it is 8 feet above the ground, when y equals to 8, right? First, we need to form a formula. The formula must have which two variables? Can you tell? The formula must have x as well as y. Look at this. This is x and this is y, right? We have 17. The length of the ladder is always 17. So let's use Pythagoras theorem formula. X squared plus y squared equals to 17 squared. This formula is involving only two variables, x and y. So we need to differentiate now. In order to differentiate this function, let's differentiate implicitly. This time, I try to differentiate implicitly with respect to time. Use another method. So differentiate implicitly with respect to time for related rates problem. Differentiate x squared, we get 2x. It is not t term, so we have to multiply dx over dt next to it. Plus, differentiate y squared, 2y is not t term. We need to tell people we differentiate y with respect to t. Equals to, differentiate 17 squared, it is just a number, we get 0. Let's substitute and answer the question. We need to find dy over dt. 2, we have no x value yet, keep it. Dx over dt, yes, we have it, 5. Plus 2, y is 8. Dy over dt is needed, equals to 0. We need x value. With y equals to 8 and the hypotenuse, the length of the ladder, which is 17, we need to find x. Y squared plus x squared equals to 17 squared. 8 squared plus x squared equals to 17 squared. So for x, you will get 15. Substitute 15, 2 times 15 times 5 plus 16 dy over dt equals to 0. 16 dy over dt will be equals to negative 150. In the end, we answer for dy over dt, which is negative 150 over 16. We can simplify it, negative 75 over 8. And the unit is feet per second. Here I show you the method after we form the formula involving two variables. Instead of using chain rule, I use implicit differentiation. I straight differentiate the function with respect to time. Then substitute the information to get the answer for dy over dt. If you don't like this implicit differentiation, for this question, we still can use the chain rule. This is method 1. Now, method 2, using the chain rule. First, you need to form y in terms of x, or x in terms of y, up to you. So writing y in terms of x, it will be equals to 17 squared minus x squared, whole thing square root. I don't consider plus minus because y in this application question is the height. Height cannot be negative, so I just consider the positive sign. After we have y in terms of x, we can differentiate now. Differentiate y in terms of x, we get dy over dx equals to, bring the power down, the same term, power minus 1, differentiate inside. 2 and 2 cut. This will be equals to negative x over square root of 17 squared minus x squared. After differentiation, we answer the question by using chain rule. Dy over dt will then be dy over times over dt. In between, we put dx equals to dy over dx, which is negative x over square root of 17 squared minus x squared times dx over dt, given by the question, which is 5. We need x, so use this technique to solve for x. We get 15. Substitute here. Use the calculator, you will get the same result. Alright, we have learned how to solve related rates problem by using chain rule, if you prefer this, or by using implicit differentiation. Let's see two more examples. I add on. A light is on the ground 20 meters from a building. This is the lights. This is the building. The light is 20 meters from a building. So here is 20 meters. A man 2 meters tall walks from the light. 2 meters tall walks from the light towards the building at 1 meter per second. Say when the man is here, the light is on, then the shadow on the building will be this long. And let's say another situation, the man comes to here, the shadow on the building will be this much. We notice the length of the shadow is changing. In fact, it is decreasing, getting shorter. So I let this be the variable y. Then the distance that the man walks, I let it be x. According to the question, the man walks at 1 meter per second. So dx over dt, the rate of change of the x, is 1. Positive value because the further the man walks, the longer the distance. It is increasing. The rate must be of positive sign. The question asks for the rate of change of the length of his shadow. What is dy over dt? When he is 14 meters from the building. Let's see first. If it is 14 meters from the building, x will be 20 minus 14, which is 6 meters. Let's draw the condition first, the triangle shape here. This is the length of the shadow y. This is the man's height 2. Here is the distance walk, which is x. The distance from the light to the building is 20. Looking at this diagram and check with the information given by the question, we know that we need to form a formula in both x as well as y. From the diagram, we have two similar shapes, smaller triangle here and the bigger triangle. When we have similar shapes, we can form ratio. 2 over y will be equals to x over 20. Cross multiply, x times y equals to 40. xy equals to 40. We have formed the formula in both x and y, two variables. Now we can differentiate. Two options. Method 1 is using the chain rule. In order to use the chain rule, we need to have y in terms of x. Y equals to 40 x to the power of negative 1. Differentiate this, we get dy over dx equals to 40 stay. Differentiate x, bring the power down, power minus 1. So here we get negative 40 over x squared. After differentiation, what do? Apply chain rule to answer the question. Find dy over dt, which is equals to dy times over dt. In between, we put dx. dy over dx will be equals to negative 40 over x squared times dx over dt, it is 1. Given x equals to 6, negative 40 over 6 squared, 36. Simplify further, we get negative 10 over 9 as the final answer. dy over dt, the length in meter per second. Or we can use method 2. Using method 2, implicit differentiation. We have xy equals to 40. We differentiate with respect to t. For implicit differentiation, in related rates problem, we differentiate with respect to time. X and y are variables. We need to apply product rule. This is u and this is v. This is u and this is v. Differentiate u, we get 1. dx over dt. Tell people that we differentiate x with respect to time times v plus u differentiate v1 dy over dt to indicate that we are differentiating y with respect to time equals to differentiate a number 0. Next, substitute the information. Dx over dt is 1, y, we need y later, plus x, which is 6, dy over dt equals to 0. To get dy over dt, it is equals to negative y over 6. Bring y to the right hand side, negative y. Bring 6 to the right hand side, divided by 6. We need y value. So when x equals to 6, xy equals to 40. Y will be equals to 40 over 6. So substitute, it will be negative 40 over 6 times 1 by 6. That is negative 40 over 36. See, we get the same result, negative 10 by 9. Six, a boat is being put into a dock by attached to it and passing through a pulley on the dock position 6 meters higher than the boat. Let's sketch it out. Here is the dock. A boat is being put into a dock by attached to it and passing through a pulley. So I have a pulley on the dock which is 6 meters higher than the boat. This is the pulley. If the rope is being pulled in at a rate of 3 meters per second, being pulled, let's say this rope, I let it be L. According to the information, dL over dt is negative 3. Why I put negative? Because when I pull this rope, the shape will be nearer to the dock, and the rope, do you notice, is shorter. How fast is the boat approaching the dock? So the question, want to know the rate of change of this. Let it be x, dx over dt equals to question mark, when it is 8 meters from the dock, when x is 8. So here, we make clear about the situation. First, we form a formula. It must be in terms of L and X. We have 6, X and L. We can apply Pythagoras theorem. L squared equals to 6 squared plus X squared. Involve two variables for this equation. We now start to differentiate. Two options. You can differentiate implicitly or differentiate by using chain rule. If you want to use chain rule, you must write L the subject. Method 1, using chain rule. Writing L the subject, we have 36 plus x squared power half. Differentiate this. dl over dx, differentiate L with respect to x. Give us dl over dx will be equals to, bring the power down, power minus 1, differentiate inside. It is equals to x over 36 plus x squared. After differentiation, apply chain rule to get the answer. We need to find dx over dt. dx over dt will be equals to dx times over dt. In between, we put dl. Will be equals to dx over dl. We have dl over dx. dx over dl is the reciprocal of it. So 36 plus x squared over x times dl over dt, which is negative 3. Given x equals to 8, we substitute x equals to 8. We will be getting 36 plus 64 over 8 times negative 3. Solving this, we will be getting negative 15 over 4 meter per second. The length is in meter, the time is in second. This is the final answer. For method 2, where we differentiate implicitly with respect to time, we don't need to have L in terms of x. We start the differentiation with respect to time. Differentiate L squared, we get 2L dl over dt equals to differentiate number is 0 plus differentiate x squared with respect to time, we get 2x times dx over dt to indicate that we differentiate with respect to time. Plug in the information. 2L, we don't have L, we need to find L. With x equals to 8, when x equals to 8, L squared equals to 6 squared plus 8 squared. L equals to 10. Substitute L10, dl over dt equals to 2, substitute x, which is 8, dx over dt. 20, dl over dt is negative 3, substitute 8, equals to 16, dx over dt. So for this, we get dx over dt equals to negative 60 over 16. That's equals to negative 15 over 4. We get the same result. First method, apply chain rule. Second method, we differentiate implicitly with respect to time. I hope by now you know how to solve the related rates problem. First, we need to form the formula. Make sure the formula involves only 2 variables. If it has more than 2 variables, you need to reduce to 2. After that, we differentiate. You either differentiate the explicit function y in terms of x, or you differentiate implicitly. When you differentiate implicitly, you have to differentiate with respect to time. For differentiation using the explicit formula, you have to apply chain rule to get the answer. For those who use the implicit differentiation, differentiate with respect to time, you can substitute all the information and get the answer. Thank you for watching this video.